Well, let's begin again on section 2.2, part B, and we're talking special angles still. And this is in the triangles of a 30, 60, 90-degree triangle and a 45, 90, and all of the trig functions involved. And then we're doing reference angles. To help us get the trig functional values. So here we are. We're now looking at the sine of 225 degrees and the cosine of 180 and the tangent of 45. So let's first look at our reference angles. All right, the 225 is right here. We're in quadrant 3, where we have negative and negative, and our angle is right there. Our reference angle is this portion right here, which is the 225 minus the 180 degrees is my reference angle. So if I do the math, I'm going to get 45 degrees. That's awesome. But I know quadrant 2, and we want the sine, so we know quadrant 2 is negative for sine. All right, so now we can do that, and that's easy now because we know that that is a negative square root of 2 over 2. All right, and the 180 is a quadrantal, and that is negative 1 and 0, and the tan of 45. Now 45 is right here. And of course we understand that the tangent of a 45 degree is 1, because the legs are the same. So now we've got our values per se. So in the sine of 225, we have a negative square root of 2 over 2 squared minus a 180 is negative 1 squared for the cosine plus 1 squared. So let's see what we've got here. We've got 2 over 4 minus the 1 plus the 1. That gives me 1/2 for that expression when we evaluate that expression. So you can see the importance. Well, now that we have discussed the importance of the special triangles, we're ready for the unit circle. It is vital to have understanding. Of the special angles to be successful in calculus. All right, so here we go. All right, so okay, now we're talking about our unit circle where the radius r always is 1. Okay, and it's positive. And here is quadrant 1, which cosine of theta sine of theta replaces xy. And we know it is positive, positive. All right. So at 0 degrees, we have 1 for the cosine and 0 for the sine. At 30 degrees, now at this point, we have, if I dropped a perpendicular, I would create this angle. And I would have the 30, 60, 90 degree triangle here. And I would have, this would be the square root of 3, this would be the 1, and this would be what we need. So let me look at that. So we would have the square root of 3 over 2 and the 1/2 for the values of the 30 degree. For the 45 degree, I would have the line coming down. Creating my right triangle there. And I would have this 45 degree angle. And we would see that x is smaller and y is larger. So this would give me the 1/2 for, I'm sorry, this is 45. Square root of 2 over 2, because these are both the same, and the square root of 2 over 2 positive. Then I would go up to the 60 degree, and I would notice that change in the x and y. And this would be the 60 degree angle. And I would have the flipping of the values. I would have 1/2 for cosine and the square root of 3 over 2 for sine, because it would be opposite. And you can see the angle is large. Then I'd come to the quadrantals, which is 90 degrees. I would have 0 for cosine and 1 for sine. And then now I'm coming into the circle, and I would see that this is 60 right there for the reference angle. And that would give me 120 degrees. And we're talking quadrant 2, where we would have again our cosine theta value and our sine theta value. And this would be negative and a positive. So I would have a negative 1/2, because the reference angle is 60. And I would have a positive square root of 3 over 2. And then I could draw my line. To make my right triangle. Again, I would see the butterfly effect. And you also have one of these to do for me, and take a picture of it. Okay? And you can see that that matches. And then this next one would be 135 degrees, which is 45 degrees. And it would be a negative square root of 2 over 2 and a positive square root of 2 over 2. And I could draw my line down. Let me undo that. Sorry about that. No, I don't want that one either. That's the best I can do. That's not too bad. And we're going to sketch that for our 45, and we can see that it is a bow tie. It's becoming a bow tie. And it matches this part right here, except for the signs, which are negative and positive. And now I'm at 150 degrees. And this would make it a negative square root of 3 over 2 and a positive 1/2, which is the reciprocal because they're co-functional. So you can see the connection of this side being negative, negative, and negative to the opposite side. You see how they're all equal? Okay, now we're going to do the bottom side. Again, the reference, and we're going to the quadrantal. And the quadrantal here is 180 degrees. It's negative 1 and 0. Notice it's the opposite of the other end of the x-axis. And then we would be going down, which would be the 210 degrees, which would be our 30. Now my bow tie is going to look kind of funny because the lines aren't cooperating, but you get the idea. And here we're talking quadrant 3. And we know cosine theta, sine theta, and they are negative and negative. Both are negative. So this would be the negative square root of 3 over 2 and the negative 1/2. And then I would have, this would be 225. And in my 225, oh, well, I drew that one. Sorry about that. And I thought I had it right. I would have this particular shape right here, and that would be negative and negative, and those are great because they're 45s. And that would be the negative square root of 2 over 2 and the negative square root of 2 over 2. And then we'd come to the larger 240. And that would give me okay, well, it's not going to be exact, but if I'd had it properly drawn, it would be beautiful. So that would give me a negative 1/2 and negative square root of 3 over 2. Then we go to this quadrantal, which is 270 degrees. And that would be 0, negative 1. And then we have the continuation, which would make it the 300 degrees, which would be positive. This is quadrant 4. So we would have the cosine of theta, sine of theta, and they would be positive and negative. So this would be a positive 1/2 and a negative square root of 3 over 2. And then we'd have the 315 for the 45, and that would be the square root of 2 over 2 and a negative square root of 2 over 2. Then we'd have the 330, which is a 30 degree, which would be a positive square root of 3 over 2 and a negative 1/2. And then we'd come back full circle. So you can see that we would have a bow ties continually going to match. This matches that and so on. So now we're using that unit circle to figure out all the values between 0 and up to 360 that have the given function. The tangent is the square root of 3 over 3. All right. Well, that meant it's negative, so it could be in quadrant 2 and quadrant 4, because that is quadrant 2 is negative and positive, and quadrant 4 is positive and negative. That's the only way I can get a tangent. Well, this looks like a rationalized function, right? So we know that the tangent of theta equals y over x. So we could have a -1 over a -3 or a +1 over a -3. So if I had that -1, I'd have the -1/2 and the square root of 3 over 2. Or I would have the 1/2, because it's a 30 degree, and the negative square root of 3 over 2 by the ordered pair that we had. So in this case, we're talking, I'm going to pause. So right here, we have to determine these ordered pairs. Well, this one is quadrant 2, and this one is quadrant 4. So in this case, we know we've got a 60 degrees. And so this one would be 180 minus the reference, which is 120 degrees. And this one is 360 minus the reference, which would give me 300 degrees. So my answer would be would give me, oh, I have those listed wrong. Sorry about that. I have them in reverse. I apologize. It's why, I mean, the numbers are just in the wrong places. I would have a -1/2 and the square root of 3 over 2. So this is a 30 degree. So this is 180 minus the 30 degrees. So that would have 150 degrees. And this would be a negative square root of 3, negative square root of 3 over 2 and the 1/2. And this is quadrant 3. You can tell it's almost the last problem and I'm making serious errors. This is quadrant 4. And that would be 360 minus 30, 330 degrees. And this is quadrant 2, which is 180 minus 30 degrees, 150 degrees. And now that is correct. So my solution would be 150 degrees and 330 degrees is where the tan of that theta is equal to negative square root of 3 over 3. Sorry about that. I paused because my phone rang. Threw me off. So we have sine as a positive. So sine is positive in quadrants 1 and quadrants 2. And so in this case, we have 1/2 for cosine and the square root of 3 over 2. So that's 60 degrees. And a negative 1/2 over the square root of 3 over 2, which would be 180 minus 60 degrees, 120 degrees. So my solution would be 60 degrees and 120 degrees. Of course, you can use for starters, your unit circle. So here, this one's easy. This is cosine is positive. Cosine of theta is positive in quadrants 1 and quadrants 4. And we know it's 45 degrees in quadrant 1. In quadrant 4, it is 360 degrees minus the 45 degrees. And that would give us 315 degrees. If I did the math right. So, our solution set would be 45 degrees and 315 degrees. In each case, challenge yourself to make the position be correct. So cosecant theta means that sine theta 1 over cosecant theta. So therefore, the sine of theta is 1/2. So sine theta is positive in quadrants 1 and quadrant 2. And to be sine is 1/2, we have a 30 degree. In quadrant 1, we would have the square root of 3 over 2 and 1/2, because sine is the second value. It's the y. So that would give us 30 degrees. And then for quadrant 2, we would have 180 minus the 30 degrees, 150 degrees. So it would show up at 30 degrees and 150 degrees. So there you have it. We've learned how to visualize special triangles to construct the unit circle. Thank you so much for listening. Now do your homework.